Finally, we are at the last law of motion, where we will be studying how objects interact with each other. Let's jump right into it. The Newton's third law of motion states that if two objects interact, the force F12 exerted by object 1 on object 2 is equal in magnitude and opposite in direction to the force 2-1 exerted by object 2 on object 1. And we write this as a negative vector to say F12 is equals to negative F21, because these are two equal vectors but they point in opposite directions. So we use this negative here to show that they are in different directions but they are equal. Let's demonstrate this using two different diagrams. Say you have a wall and we're trying to push this wall. Now I'll call this person here object 1. Let me use a different color. So this is object 1. And I'll call the wall object 2. Now this means the force that is applied by the person on the wall will point in that direction. So this will be the force of the person 1 on the wall 2. Right? And I'll choose my direction such that it sits like this. Right? So this force is positive here because it goes in the positive x direction. Now Newton's third law says the wall will push back on the person. The wall will push back on the person here in that direction. So this will be the force of the wall 2 on the person 1. Another scenario that perhaps I want to share, let's say we have the Earth's surface sitting like this. So this is Earth. And let's assume that there is a ball here on the Earth's surface. We already know and defined in the previous lessons that the Earth will exert the force of gravity on the ball. It will pull the ball vertically downwards. Now I'll call the Earth 1. So it's object 1, and I'll call this ball here object 2. So this will be the force of 1 of the Earth on the ball, F12. Now we're saying that this force here is the gravitational force. Because it's the force that the Earth is a non-contact force, right? The attraction force that the Earth is exerting or pulling the ball with. Now, the third law of Newton is that if the Earth pulls the ball will also pull the Earth with a force F2, the force of the ball on the Earth. But now this force will go in the negative direction, will go in the opposite direction, because in this case I'll choose my direction like this. I'll say anything that goes down is positive, so that this force here is positive and this one is negative. Just to quickly also go back to the previous one, we said that this force will be positive because it's going in the positive x direction, so this means this one here has to be negative. meaning these two forces F1 2 is equals to negative F2 1. Even here with the earth, we'll have the same thing to say F1 2 is equals to negative F2 1. The two forces are equal, they are equal, but they point in opposite directions. They're equal and they point in opposite directions. Another interesting thing just to entertain with these forces is that sometimes some people like to call them action reaction forces. I don't know where these statements come from and why people are using it, because it is wrong. And I'll explain why. If you say action reaction, it implies that the first force was an action and the other one was a reaction as a result of the first force. So for example, if we go back to our scenario here, this would mean that this force here is an action force because it's the person who started to push the wall. Then as a result, the wall reacted with the same force but in the opposite direction. That's not true. That's not what happens here. The person will, start pushing the wall so that there is this force that is being exerted on the wall. But what happens is that as soon as the person touches the wall, simultaneously, the wall will also exert the force in the opposite direction. These two forces occur simultaneously. They occur at the same time. They don't occur as a reaction, as an action-reaction pair. So in the same way, if this object is to be located next to the Earth's surface, the Earth will pull it towards its center, and immediately this object will also pull the Earth in the opposite direction. So they're not action-reaction pairs, they occur at the same time. But this is something that you'll often get even in your question papers. Just know that they refer to a pair of Newton's law of forces, right, that are exerted by two objects when they interact with each other. Sometimes Newton's third law can be referred as just N3. Right, so the conclusions of N3 are as follows. What can we learn from this law, or what does this law say when we break it down? And this is important for you to identify these laws when you solve our questions. So Newton's law of motion occur as a pair of forces acting on different objects, right? So these forces will always be a pair. So if we go back to our examples here, you'll find out that it will be this force, right, acting on the wall, and this force exerted by the wall on the person, acting on the person. So it's always a pair, right? These forces occur as a pair, and they act on different objects. This one is acting on the wall, this one is acting on the person. The same is true with the scenario here involving the Earth, right? This force here acts on the ball and it comes from the Earth, right? And this one is experienced by the Earth and it comes from the ball, right? So it's a pair of forces. It's two forces acting on two different objects. Another conclusion or observation that you should be able to see with Newton's third law is that it is true for both contact and non-contact forces. So now here we have contact forces. These two forces are regarded or classified as contact forces because when you push vertically straight on the wall, right, you'll create an angle of 90 degrees here, right? And the wall will push back with an angle of 90 degrees there because these forces are directed on the horizontal, right? They make an angle of 90 here. So in other words, these two forces are normal forces, right? If you want to understand what normal forces are, please go to lesson 2 where we study categories of forces. Right? Now, normal forces, remember we said they are contact forces, right? So Newton's third law works when we have contact forces, and I mean these are contact forces also because these two objects are touching each other, right? And then in this case, remember we also said in our lesson 4 when we studied gravitational forces, non-contact forces. No, lesson 2, we said that gravitational force is a non-contact force, right? The earth is pulling the ball and the ball is pulling the earth, but the two are not touching each other, right? So we can still apply Newton's third law even if we're dealing with non-contact forces. Another conclusion that can be drawn from N3 is that the pair of forces must be of the same type. So as I was explaining here, these forces can also be understood to be normal forces, right? So they are both normal forces. They're the same type of forces, right? This force here is a non-contact force called gravitational force. The earth is pulling the ball and the ball is pulling the earth with a gravitational force as well. So both of these two forces are gravitational. They are of the same type. You can't have friction and the normal force being a pair of Newton's third law, right? You can't have gravitational force and let's say tension, right? It cannot happen. They must be of the same type. Another observation that we make with Newton's third law is that the forces act in different direction, right? Shown by the negative sign, right? But the magnitude is the same. So this one is clear. We talked about it a lot when we looked at these laws. You know, these forces are of the same magnitude, but they only vary with direction here. The other one goes to a positive direction, the other one to a negative direction. So what we're saying here is that if this force is 10 Newton, we'll also get 10 Newton here, but it's going to be negative because it goes in the negative direction. If this force here is 15 Newton, we will also get here 15 Newton, but it goes in the negative direction, so we'll have a negative right there. All right. The last conclusion that we see with Newton pair forces is that they do not add to a resultant force of 0 because they act on different objects. Now this is very, very important, and it's easy to make an error with this one. If I were to draw a free body diagram of the wall, right, I will have a force that is sitting like this, F1, 2. Remember, this is the wall, right? We said the wall is object 2. In fact, we said the wall is object 2. Now, if I were to calculate the net force here on the wall, I would say the net force or the sum of forces in the X is equals to F1, 2, and there are no any other forces to add here according to this free body diagram. If I look at that wall, there are no any other forces, right? So do you see that I'm not adding on this equation this force and this force, because the other force is acting on the person, it's not acting on the wall. If I were to draw the free body diagram for the person, it will be 2, 1, right? And it's negative. Do you see here that the only force acting on the person is that of the wall on the person, right? So if I were to add the forces again, it will be simply adding that single force, right? They act on different objects, so we cannot add them. And the same can be applied or seen in this scenario as well, right? Newton's pair of forces do not add to 0 because they act on different objects. Guys, this is the only things that you need to know with regard to this law. It's straightforward and simple to understand. We will do some questions to practice on it. as we are getting closer to the end of our lessons, where now we'll be solving problems. Thank you for watching lesson 6. May the force be with you.